Migrating Kafka workloads to cloud environments or implementing disaster recovery across hybrid infrastructures requires managing replication infrastructure and coordinating producer and consumer movements between clusters. You can now replicate data from external Apache Kafka clusters, whether on-premises, self-managed on AWS, or on other cloud providers, directly to Amazon MSK Express brokers using MSK Replicator. This automates the replication process without requiring you to configure open-source tools or manage custom infrastructure. You retain your original Kafka topic names during replication while the service automatically prevents infinite replication loops. MSK Replicator synchronizes consumer group offsets in both directions, allowing you to move producers and consumers between clusters independently without coordination requirements or data loss risk. You can also replicate from MSK Express back to external clusters for failback scenarios or multi-cloud data distribution. When replicating data bidirectionally between Kafka clusters, you need to ensure applications can resume processing from the correct position when moving between clusters. Previously, MSK Replicator synchronized consumer group offsets only when producers and consumers were active on the same cluster, requiring you to carefully sequence application migrations and risking duplicate message processing during rollbacks. With enhanced consumer offset synchronization, MSK Replicator now synchronizes consumer group offsets across source and target clusters regardless of where producers are running. You can synchronize consumer offsets across bidirectional clusters, enabling independent movement of producers and consumers between clusters. This removes coordination constraints during application migration and prevents data loss and duplicate message processing. You can enable this capability when creating a replicator using the MSK console, AWS CLI, or CloudFormation in all regions where MSK Replicator is available. Upgrading database versions traditionally requires creating new clusters, changing endpoints, and rebuilding indexes, causing disruption and complexity. Amazon DocumentDB now enables in-place major version upgrade from 5.0 to 8.0 through the console, SDK, or CLI. You can upgrade without creating new clusters, changing endpoints, or rebuilding indexes, eliminating operational overhead. Version 8.0 reduces query latency by up to 7x and improves storage compression by up to 5x, enabling your applications to run faster while consuming less storage. You gain access to new capabilities including collation for language-specific sorting, views for data abstraction, additional aggregation stages and operators, enhanced text search with text index v2, and vector index builds that complete up to 30x faster. The in-place upgrade is available at no additional cost in all regions where DocumentDB 8.0 is available. When replicating data between Kafka clusters using MSK Replicator, you previously relied on CloudWatch metrics to monitor replication health, making it difficult to diagnose specific issues without contacting AWS support. You can now enable log forwarding to gain visibility into replication events and errors. The logs surface common replication errors such as insufficient permissions on source topics, partition quota exhaustion on target clusters, and records exceeding size limits, and provide guidance on how to resolve each issue. You can also track steady-state replication activity including offset commits, topic discovery events, and Kafka client errors or warnings. You enable log delivery when creating or updating a replicator through the MSK console, AWS CLI, or CloudFormation, and forward logs to CloudWatch, S3, or Data Firehose based on your requirements. This capability is available in all regions where MSK Replicator runs, with cost depending on your chosen destination service. Organizations managing multi-account EKS environments face challenges enforcing security and compliance requirements consistently across clusters without manual processes or post-deployment checks. Amazon EKS now supports 7 additional IAM condition keys that address this by enabling proactive policy enforcement through IAM policies and service control policies. You can enforce private-only API endpoints and require customer-managed KMS keys for secrets encryption to meet security standards. You can restrict clusters to approved Kubernetes versions to maintain consistency across your environment. You can mandate deletion protection for production workloads to prevent accidental cluster removal. You can also specify control plane scaling tiers and enable zonal shift capabilities for high availability requirements. These condition keys apply to create cluster, update cluster config, update cluster version, and associate encryption config APIs, integrating with AWS Organizations SCPs for centralized governance across accounts. The feature is available in all AWS regions where EKS is available at no additional charge. When managing objects and latency-sensitive applications using S3 Express OneZone, you need an efficient way to track stored objects and their metadata without relying on synchronous list API calls, which can impact performance in workflows and compliance audits. S3 Inventory addresses this by providing a scheduled reporting alternative. You can configure daily or weekly inventory reports for objects in your directory bucket or specific prefixes. You can specify output format as CSV, ORC, or Parquet to match your data processing requirements. You can select object metadata including encryption status to verify compliance with security and regulatory requirements. You can use CLI, SDKs, or API for configuration, integrating inventory generation into your existing infrastructure management tools. This enables you to simplify business workflows, accelerate big data jobs, and maintain compliance without impacting application latency. Edge IoT deployments face constraints around security policies that prohibit root access and resource limitations on devices with minimal memory. You can now install and run AWS IoT Greengrass v2.17 as a non-root user to meet security requirements in enterprise and regulated environments. You can deploy lite components that significantly reduce memory consumption, including a secure tunneling component that uses 4 megabytes instead of 36 megabytes. You can simplify dependency management through automatic uninstall lifecycle capabilities that activate when you remove a component. You can leverage PKCS number 11 interface support to authenticate with AWS IoT Core using keys and certificates stored in hardware security modules, and use TPM 2.0 in the fleet provisioning component for cryptographic operations and device identity management. When migrating VMware workloads running Windows Server to AWS, you need to manage licensing for those virtual machines while meeting data center exit timelines. Amazon EVS now offers Microsoft Windows Server licensing entitlements that address this requirement. You can obtain Windows Server licenses directly from AWS for your VMs running in EVS, eliminating the need to bring your own licenses. You configure entitlements by connecting EVS to your VMware vCenter server and specifying VM IDs through the console or AWS CLI. You pay per vCPU hour for entitled VMs only, providing cost transparency and control. You add or remove entitlements at any time as your environment changes, giving you flexibility to manage licensing costs dynamically. This capability enables you to migrate Windows Server workloads to AWS while maintaining your VMware environment and meeting critical data center exit deadlines. Managing local administrator passwords across domain joint computers presents security risks when passwords are static, shared, or manually updated. AWS Managed Microsoft AD now runs on Windows Functional Level 2016 across all directories, automatically applied to existing deployments. You can run directories on the upgraded functional level to access enhanced authentication mechanisms and privileged access security features. You can implement LAPS, Local Administrator Password Solution, to automatically generate and rotate unique, complex passwords for local administrator accounts. You can manage these passwords securely stored in Active Directory, reducing the attack surface from shared credentials. The upgrade is available in all AWS regions where AWS Managed Microsoft AD operates, except Middle East, UAE, and Middle East, Bahrain.